All right, welcome back, everybody. Now, I know I told you that we wouldn't be doing any of our geometry unit on videos, but with me being out of town, we don't really have the days to fall further behind than we are. So the next couple of lessons we're going to be doing here on the videos, they should go quick. We'll review together, and then these videos should go pretty quick for all of you. But with me being gone, you'll have the ability to rewind, to rewatch them if you get stuck and you're not sure what to do, and you have questions about what's going on. So in case you have forgotten, volume. We're talking about volume of prisms, and we've got some prisms down here below if you don't remember what a prism looks like. But when we're finding volume, what we mean by volume, probably the easiest way to look at it is the space inside the object. Or in other words, like if we were to take these objects below and if we were to fill them up with water, volume is how much water it would take to fill up the object. So how much space is inside. And if you need to write that up here, that volume is how much water it will hold, if you want to write it that way, or how much space is inside the shape. All right, now volume is in 3 dimensions. We have a length, we have a width, we have a height. It's never going to be 2-dimensional, it's always 3-dimensional. If you think about a piece of paper laying flat on the table, we can't really fit any water inside the piece of paper. We need 3 dimensions. We need not just the length and the width, but we also need the height of the object. So I'm going to give you a basic formula, especially because I'm gone. Just a simple formula that you guys can use to find the area, or excuse me, to find the volume of your prisms. Now, in the past, we've used B to stand for like the base, like when we do length times width or base times height. What little b is going to stand for in our problems, little b still stands for the length of a side of our object. So little b still stands for the length of just a side. What big B is going to stand for, big B is going to stand for the area of the base of our shape. So big B is going to stand for the area of the base of our shape. And big B is going to be important when we're finding volume. It's going to be kind of the key to figuring out the volume of prisms. And I'll give you the formula here in just a minute and kind of show you what that looks like in the problems down below. So formula for volume of any prism, well, let's just give it to you how it is now. The first step in using this formula is standing the shape up on its base. If you notice that our first shape down below, it's laying down on one of its lateral sides. It's not standing up on its base. The base of this triangular prism is these triangles at the top and the bottom. It's just laying on its side. So one of the ways that I've tried to remind you how to tell what the base is, if you were looking at the shape and you thought that the base was this rectangle, my shape, for the base to be a rectangle, my shape has to look like a package of graham crackers. Okay, if my base is a rectangle, then my shape looks like a package of graham crackers or saltines or a cardboard box. If my base is a triangle, then my shape looks like this one, or even this shape over here that's also a triangular prism laid down on its side. So the first thing that we need to look for is the base of our shape, because we need to find the area of that base. And we're really just looking at how many times we stack that on top of itself. So for our formula, we need the area of the base, which is big B, the area of the base of our shape, and we're going to multiply that by the height of my shape. Okay, we're going to take the area of my base multiplied by the height of my shape, and that's going to equal volume. And one of the ways to look at this is, let's say that I had a package of saltine crackers. My base is one saltine cracker. So the area of my base is just my saltine, and the height is how many of those saltines are stacked on top of each other, and that's going to give you the volume of the saltine crackers. So in this shape right here, the first thing that we need to look for is big B, or the area of my base. And we've talked about this already, but my base is going to be this triangle right here in the front. So I'm going to actually write out the formula here. I'm going to write out big B is going to equal the area of that base. And since it's a triangle, I take my length times my height, and I'm going to divide that by 2. That's the area of my base. So 10 times 12 is 120, divided by 2 equals 60. So 60 represents big B. That's the area of this triangle. Now I want to know how many of those triangles am I stacking on top of each other to get my height. And so I just look over here for my height, and my height of my prism is 16 meters. That's how many of these triangles are stacked on top of each other, 16 of them. So for my formula up here, I plug in big B, 60, and I'm going to multiply that by h, my height. How many of them are stacked on top? 16 of them. So 60 times 16, and that's going to equal my volume. Okay, so in my calculator, we'll do 60 times 16, and that gives me 960. So my volume equals 960, and since we're working in 3 dimensions, that's 960 meters cubed, because we have a length, we have a width, and we have a height. So my units are cubed. And that's it. That's all you need to know to find the volume of a prism. You find the area of the base and multiply that area by how many of them are stacked up, or the height of the object. So up here, if you need to write underneath h, this is the height, or how many bases are stacked, if that helps you remember better. And then big B right here is the area of the base. So the only mistake I see you people making, other than the common, forgetting to divide the triangles by 2, is going to be not using the right base. If the shape is laid down on its side like this one, or like this shape, or like this shape that's laying down on its side, we need to make sure that we stand them up. The nice thing about these ones, the rectangular prisms especially, if I look at this, I think that my base is this rectangle on the bottom. And if I look at my overall shape, yes, that looks like a package of graham crackers, or a box of cereal, or a package of saltines. So I know that my base is a rectangle, and with rectangles, we don't really care which one we use as the base, but we're going to use this one that's on the bottom. That's the one that we're going to use for our base. So big B, the area of that rectangle sitting on the bottom, that rectangle is 3 by 2, so it's just 3 times 2, which is 6. So the area of that base is 6 inches squared. And now I want to know how many of those are stacked on top of each other. So how tall is this object? And it's 6 inches. So my height is going to equal 6 inches as well. So my volume equals big B, which was 6, the area of my base, times the height of my object, which was also 6, which is going to equal 36 inches cubed. 36 inches cubed. Now we're going to present some of these in different ways. Sometimes they give you just a picture with the object. Sometimes they give you a story problem. Sometimes, like this problem below, this is the last one I'm going to do for you, and then I'm going to let you do the other 3 by yourself. But this one, it gives us big B. It tells us the area of the base, and not only that, but it actually points it out to us so that we know what the base is. But the area of the base is 80 meters squared. And if I look at the height of my object, it tells me right here that this is 11 meters tall. So I've got 11 of those bases stacked up. So when I do my formula, volume equals big B, which is right there, 80, times my height, which was this number right here, 11, and that's going to equal my volume. So on my calculator, I can just put in 80 times 11, and I get 880 meters cubed. And that's it. So a couple things to be careful of. Triangles. If you're using triangles, make sure that you divide by 2, like we did at the beginning to find the area. The second thing to be careful of is that the base is on the bottom, that your shape is standing up the way it is supposed to. Remember, if you think your base is a rectangle, which some of you are going to do, some of you are going to look at this shape right here and think that the rectangle is my base. But when I look at my shape, it doesn't look like a box. So my base can't be a rectangle. My base has to be this triangle on the side. So what I would like you to do, you've got 3 problems here. You've got a triangular prism laying down. You have a story problem here in the middle, and then you have our pentagon prism here that's also laying down that gives you big B. I want you to solve those 3 problems. You can take your solutions up to the substitute. If everything looks good, she will give you the practice for you to do on your own to spend the rest of the day on. So good luck.